Welcome, class. Today we'll be talking about our truth tables. These are tables in which we're trying to determine the truth of a statement. Usually this is a conditional statement. Sometimes it's an if-then statement. But either way, what we will be using is going to be P's, Q's, and R's. And each one of these P, Q's, and R's will be representing some sort of statement. And for instance, I might say P is, for instance, P could be Mr. H is wearing red. And let's just say Q ends up being it is test day, and R is pigs can fly. There's a few other notations we need to talk about. This a tilde negates whatever I have. If I had a tilde P, it would be saying not P. So Mr. H is not wearing red. If I would do something weird like negate not P, well, that's doing the not of the not. Double negative makes it back to what it originally was. So I could rewrite all this, but all it would be is Mr. H is wearing red. Okay, so we have a statement, P, Q, and R. It's some statement that is either true or false. The tilde in front of it means it's not P. We're good so far. The next symbol we need to talk about is imply, or what it makes to be if-then form. So for instance, P, then Q. That would read, to me, if P, then Q. Or if Mr. H is wearing red, then it is test day. Whether that is true or not, that's how I would be able to read this and make it a lot easier in my hand to write. We just did conditional statements where we were writing whole sentences. Instead of doing that, I could have done this. Especially when I decided to write the converse, the inverse, and the contrapositive. So if I was trying to write the converse, inverse, and contrapositive of this, the converse, I just switch it around. There, I have the converse. For the inverse, there, I have the inverse. If not P, then not Q. And last but not least, the contrapositive. If not Q, then not P. I said before that the conditional and the contrapositive were equivalent. It's real easy to see in a truth table why that is. Please remember these three here. I'm going to be erasing them shortly to do a truth table. But a truth table is just a real nice way to gather information all into one location. Alright, in a truth table, I have to think of all possible cases. When P is true, Q can be both false and true. When P is false, Q can be also, again, false and true. That's the only cases that I could have here. So let's just real quickly look at the different types of statements I can make. I can make my original conditional statement. If P, then Q. Well, the only time a conditional statement is false is when a promise has been broken. The condition has been met, but the consequence was not delivered. So for instance, if P, then Q, if Mr. H is wearing red, then it is test day. Well, if I was wearing red and it wasn't test day, that is a false conditional statement. The condition was met, but the consequence was not. If P, then Q, both being true, the promise has been met, or the condition has been met, and the consequence has been done. If Mr. H is wearing red, then it is test day. So in this case, Mr. H is wearing red and gave a test. Alright. Here's the thing. If the promise hasn't been broken, the condition not being met, then we give it the benefit of the doubt. So for instance, if P, then Q here, well, the condition hasn't been met because P is false. So in this case, even though the consequence was not done, the condition wasn't met, so it's a true conditional statement. If Mr. H is wearing red, then it is test day. Now, if Mr. H isn't wearing red, it could still be test day. And same thing here. Condition wasn't met, but it ended up being test day. That's just fine. Alright, what if we decided to look at the converse? So here was the original. Here's the converse. If Q, then P. Well, let's decide here. If false, so the condition has not been met, then true. Well, if the condition hasn't been met, innocent till proven guilty. We give it the benefit of the doubt, however you want to look at it. If true, then true. Okay, yep. Consequence and condition were both met. That's entirely fine. It's true. If false, then false. Well, the condition has been met, so anything that happens with the consequence, benefit of the doubt. And last but not least, if true, then false. Well, the condition has been met. It is test day. But Mr. H is not wearing red. Therefore, if P, then Q actually has the promise being broken, or the condition being met, but the consequence not happening. All right, let's look at the inverse. If not P, then not Q. In fact, it might actually be beneficial to make two more columns here. So here, not P, all I do is I look over here at P. If it's not P, then if it's true, then it's false. So not P, P is true, so not P is false. P is true, not P is false. P is false, not P is true. Same thing with not Q. Q is true, so not Q is Q is false, so not Q is true. Q is true, so not Q is false. Q is false, so not Q is true, and Q is true, so not Q is false. Now that I have this here, let's do if not P, then not Q. Not P, then not Q. Condition hasn't been met. Give it the benefit of the doubt. Not P, then not Q. Condition hasn't been met. Benefit of the doubt. If not P, then not Q. True condition. So the only way this is going to be false is if my consequence is false. However, in this case, it's true. So if true, then true. Perfectly fine. Consequence and condition both met. If true, then not false. Well, condition was met, consequence wasn't carried out. It's a false conditional statement. If I look at this column here and this column here, I notice that they are one and the same. The inverse and the converse are equivalent statements. The truth table shows it. And the last column, if not Q, then not P. So not Q, then not P. Condition met. Consequent not given. False. If not Q, well, that's false. Condition has been met. We give it the benefit of the doubt. If not Q, then not P. True condition, true consequence. That's a true conditional statement. And last but not least, condition hasn't been met because not Q is false. So therefore, we're good there. This one with double arrows and this one with double arrows. The entire column is identical. So the conditional statement and its contrapositive are equivalent. This is how you write a truth table. Something like this. And this is how you determine truth value for them. If you have more questions, please feel free to ask. I tried looking for some other videos, but they added in things that I didn't want, like the and symbol. Ooh. I think this is the or symbol, and then this is the and symbol. They added in other symbols that I did not want or decided not to do for this one around. But that's all you really need to know here is how to determine when it's true, when it's false, and how to make a truth table. Till next time.